morning everyone. Myself Tejashwi Navina from ECE Section B. I am going to present about clock signal and triggering. First of all, I am going to give a brief introduction about sequential circuits followed by clock signal and triggering. Sequential circuits. Sequential circuits are digital circuits that store and use previous state information to determine the next step. Sequential circuits are similar to combinational circuits, yet they contain a memory element which stores the previous output. The sequential circuit produces an output based on current input and previous output variables. Unlike combinational circuits, we cannot control the sequential circuit. So we use clock signal to control the circuit. In sequential circuit, a clock signal is used to synchronize the flow of data and control the sequence of operations. What is clock signal? In synchronous circuits, the output changes state only at a specified point on the triggering called the clock. It allows the input to enter the circuit when triggering occurs. A clock signal is an off state. It does not allow the input to reach the circuit. In this way, we can control the sequential circuits. It ensures that all the components in circuit operate in sync with each other. It controls the timing of data transfer between components. It ensures that the data is transformed when the clock signal is in specific state. Now, earlier I said triggering. So what is triggering? It refers to the process of changing the state of a flip-flop or other sequential circuit in response to a clock signal. Triggering is of two types, level triggering and edge triggering. Level triggering. The state of sequential circuit or flip-flop changes as long as the clock signal is at a certain level, either high or low. It is of two types, positive level triggering, negative level triggering. Positive level triggering. The circuit changes state when the clock signal is high. Negative level triggering. The circuit changes state when the clock signal is in low state. Controlled latches are examples of level triggering. Similarly, edge triggering. The state of flip-flop or sequential circuit changes only when the clock signal transitions from one level to another, either rising edge or falling edge. It is of two types, positive edge triggering and negative edge triggering. Positive edge triggering. The circuit changes state on the rising edge, that is, transition from low to high of the clock signal. Negative edge triggering. The circuit changes state on falling edge, that is, transition from high to low of the clock signal. Flip-flops are considered as edge trigger. Now let's discuss about some of the differences between edge and level triggering. Edge triggering is based on detecting a sharp edge in the input signal, whereas level triggering is based on recognizing a specified signal level, that is, high level or low level. Edge triggering is particularly helpful in applications that need precise timing. Level triggering lacks the ability to regulate precise timing. Finally, to summarize, triggering in sequential circuits can be either level triggering based on the level of the clock signal or edge triggering based on the transition of the clock signal. Positive and negative variations exist for both level triggering and edge triggering.
Here are the references used to make the presentation. Thank you very much.